Foundation on Solving Trigonometric Equation, a series specially developed for those who want to start from the very basic and learn all the concepts. Welcome to our series on trigonometry. We will understand few basic solutions for trigonometric equations and then move forward. In this video, we are going to discuss how do we provide a general solution for the given trigonometric equation. We'll write down answers in both degrees and in radians. I am Anil Kumar. Welcome to my YouTube channel. You'll find thousands of videos which can help you understand the concepts and master the techniques. These videos are arranged in organized playlists which can further help you to focus on any particular topic. Explore and learn with Anil Kumar. Now, let's take up the solution of these questions one by one. The very first one here is sine x equals to half. Now, when we are providing a general solution, we have to see all possible solutions within the normal domain of 0 to 2 pi or 0 to 360 degrees. As you can see, we are looking for a positive value. That basically means that in a coordinate plane, for sine, if we write the cast rule, the solution should be in quadrant 1 and in quadrant 2. So that is where we are looking forward for a solution. So always first step is to find related acute angle. So we'll write down here sine alpha equals to the positive value, which is half. And we know alpha is sine inverse of half. And to find sine inverse of half, you can always use a special triangle. Calculator is not really required. And that gives you the value. Let me make one triangle here. This is the special triangle we were looking forward. 1, 2, square root 3. And this side will give you, this angle will give you side opposite as 1, hypotenuse 2. And you know this angle is pi by 6 or 30 degrees, correct? And so we have this solution as 30 degrees, or you can write this as pi by 6. So those are your solutions in degrees and radians in quadrant 1 for the given situation. Now second step is to write the solution between the interval 0 to 360 degrees, right? If you are working in degrees, or from 0 to 2 pi if you are working in radians. So we know now 30 degrees is one solution. The other one will be 180 minus 30, right? So we can say, well, x is equal to 30 degrees, or it is 180 minus 30, right? So that will be 150 degrees. That will be in degrees, or in radians, you can write pi by 6 and 5 pi by 6. One less pi by 6 than pi, right? So we get the solution which is from 0 to 360 degrees. So that is another step. The last step is to how do we write this as a general solution, right? That is what we are looking into. I'm taking this opportunity to walk you through all these steps so that things are absolutely clear. So first step was to find the related acute angle, then all possible solutions within the standard domain of 0 to 360 or 0 to 2 pi, And then to generalize it means we know the sine waves are periodic, right? So that is the sine wave, correct? What we are looking for, the value of half means, so all these points, right? All these points. Now, time period for one cycle is 360 degrees or 2 pi, correct? So the general solution should be what? So x equals to 30 degrees plus 360 degrees, correct? Or 150 plus 360 and every 360, right? So 360n, you get the whole idea. 360n. The other one is 150 degrees plus 360n. So these two become your general solution in the given situation, correct? You could always factor 30 in the first case and then write down a simplified version, correct? Similarly, you could also factor and write down a simpler case in the second one. Now, here when we write this, we say n belongs to set of integers. Because you could go counterclockwise when n is positive, one full circle, many circles for that matter, or clockwise when n is negative. Now, same thing if you want to write in radians, in that case, the answer will be x equals to pi by 6 plus every 2 pi n, right? Or this is one, right? The other one is 5 pi by 6 plus 2 pi n. So that becomes your general solution for sine x equals to half. Is that clear to you? In a very simple way. So I'm not really factoring and writing one expression. But you can get all these solutions from here. So I hope these steps are absolutely clear. We'll take up cosine function now. And I'll give you a general expression in a very concise way. So I hope the steps are absolutely clear. Let's move on to the next question, where we'll find the solution for cos of x equals to minus half. Now, cos of x equals to minus half means we are looking into coordinate plane. Again, think about the cos rule. Cos being negative means you are in quadrant 2 and 3, right? So that is where you have this value of minus half. And minus half also reminds you of a special triangle. You need not use calculator, where 1 to square root 3. So I prefer to make this 30, 60, 90 triangle, correct? And this angle, which is 60 degrees, gives you cos of half. So now from here, related acute angle, cos of alpha equals to half. Related acute angle means less than 90 degrees, and in quadrant 1, all are positive. So even if we want to find a negative half value, we have to find cos alpha as half, correct? Makes sense. So that gives you angle of, here in this case, 60 degrees, or you can say pi by 3. Perfect. So we have the related acute angle. Next step, as we saw earlier, is to provide all the solutions within the domain, which could also be written as 0 to 360 degrees or 0 to 2 pi. Both 0 and the boundary condition 360 or 2 pi is included when we write like this with square brackets, correct? So we are looking for two solutions, and you know this is 0, this is 180 or pi. So what you see here is that that is a related acute angle alpha, right? So what we notice here is that the answer is pi plus or minus alpha. You see that? pi plus or minus alpha is your value, correct? So in this case, alpha, or you can write, we go write 360, 180 plus or minus 60 degrees, correct? So in general, that is the value which you are getting, correct? So in this particular case, let me just calculate this and figure it out. Let me write the degrees first, as we had been doing earlier also. So, so the angles here will be 180 plus or minus 60 degrees, right? Which gives you two values, of course, and one is 120 degrees and the other is 240 degrees, correct? So these are your two solutions, correct? So whenever you get this angle alpha, you can do pi plus minus alpha. If you're working in radians, then it is uh, pi minus pi by 3, which is, we'll write plus minus pi by 3. And so these two solutions will be 2 pi by 3 and 4 pi by 3. You get the idea. So you get the two angles for, these are the solutions for cos of x equals to minus half, right? So these are the x values. You get the idea. X value is the angle which we require. But this is not a general solution. Now, I'll show you a strategy of writing general solution in a very concise way, right? So we'll now think about general solution. Remember, the solution we just got could also be shown like this. We just found that the solution in this particular case is kind of like this, right? So this angle right there is what we're looking as general solution. So this angle is 120 degrees, right? Now look here, you also notice that the angle from the other side is also 120 degrees, right? But this one is minus 120. Since you are going in the clockwise manner. So it is minus 120 from this location, right? Now, here is what every cycle ends, and the period of the cycle is 360, and therefore we can write the value of x as equals to 360n, right, plus or minus 120 degrees. You see that how simple it is now. So in the last case we were adding 360 degrees, but we can concise the whole solution right like this. Similarly, if you are working in radians, one full cycle is 2 pi, so we could write 2 pi n, right, plus or minus. Now that is what we saw was 2 pi by 3, correct? So just one angle will work for you, right? So we get this as 2 pi by 3, where of course n belongs to set of integers. Do you see that beauty? So instead of making it more complicated, we could have written in this way also a general solution, correct? Now the idea here is to find the related acute angle first and the actual angle, the very first one, which will give you the right answer. So I hope that makes sense, right? Now let's look into the general solution for the cosine for tangent function, the last one. Now we are looking into tan of x equals to minus square root 3. So tan is negative in which quadrants? Tan is negative in these quadrants, correct? You can use the cost rule. So we know the cost rule. We know tan is positive in quadrant 1 and 4, 1 and 3, but negative in 2 and 4. So we'll find tan alpha equals to square root 3. Special triangle, as you know, we had been sketching for all these examples, will again be sketched. So 1 square root 3, right? And 2. So tan is that angle, right? So alpha will give you 60 degrees or pi by 3, correct? So you know how to find this solution. Now the whole idea is to how do we generalize it? Now tan has a period of pi, correct? Tan has a period of pi. So you can see what really happens here is that to get to this value of negative, we'll find two solutions first. So we say what is x equals to? Now we are trying to solve this equation tan x equals to minus square root 3. So x is equal to within the domain 0 to 360 degrees, let's say, or 0 to 2 pi, right? So within that domain, we have two answers. One you can see is right there, right? And the other one is this, correct? So these are the two solutions which we are looking into, right? Now the first one here is because the angle is 60 degrees acute angle, 120 degrees. The other one here is you will also write minus 60 degrees, right? Or you write 360 minus 60 or 300 degrees. As far as the radians are concerned, the angles will be 2 pi by 3 and 5 pi by 3. So these are the two solutions within 0 to 360 or 0 to 2 pi. But our interest is to write a general solution, right? So for general solution, let's look at it in a different way. We have two solutions right there where that is the angle alpha, right? So what really is happening is that from pi you are subtracting alpha, and from 2 pi also you are subtracting alpha to get the answer, correct? So every cycle you're subtracting the related acute angle alpha. Now in our case alpha was this. So related acute angle in degrees was 60 degrees and radians was pi by 3. And therefore we can now write down the answer x as equal to n pi minus alpha, which will be pi by 3. Or you could write this as n times 180, which is 180n, minus the angle alpha, which is 60 degrees. You see that? So that becomes a general solution for tan x equals to minus square root 3. So I hope you got the idea of how do we write a general solution when the trigonometric equation is given in a simplified form. Now this is very useful since even in a factored form, you will get to this stage at the end before writing your answers. So once you understand this, you can actually write solutions in general for any trigonometric equation. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.